Hello 171 class, this is your notes for part 2 from section 1.7, and what we're talking about here is the composition of functions. And what we mean by the composition of functions, which we use this notation f of g of x, is we're putting one function into another function. So the input of one function is the output of another function, basically. So what it looks like here is x is going in to g, right? And then this entire function's output, g of x, is what's going into f, okay? So let's just show you so you can kind of see it done so you can practice. So this is f takes an input, triples it, subtracts 4. G takes an input, squares it, doubles it, subtracts those two, and then adds 6. So f of g of x, this is telling me to put g into f. So what that means is this x right here is going to be replaced with this entire function. All of this is going to go in place of that x. So we're going to write a 3 and then a parentheses, all of this, so that's where the x is. And then we're going to subtract 4. Okay, so we just replaced x with that. Then we distribute and simplify. So always simplify these. So just put it in there. So 3 gets distributed through. And then still the minus 4. Then you combine your like terms. 18 and the minus 4 combine to a 14. Alright, so there's f of g of x. Now for part B, this is g of f of x. So what that's saying is put this function into the g function. So now both of these x's, you do it for every x. So both of these x's, I'm going to replace them with 3x minus 4 in both positions. So I'm going to end up with x squared. I'm going to put a parentheses. I'm going to put this 3x minus 4 in there. All right, and then minus 2. There's another x. I'm going to put a parentheses and replace it with 3x minus 4. Always put a parentheses there where the x was. So if you have to distribute or change the signs or something, square it, you have it set up correctly. Alright, so something's being squared, minus 2 times something plus 6. Something's being squared, it's the 3x minus 4. Minus 2 times something, minus 2 again times the 3x minus 4. And then we just simplify this. So I'm going to square the 3x minus 4, which means to multiply by itself. And then I'm going to go ahead and distribute the minus 2 through. So minus 2 times 3 is minus 6x. Negative times a negative is a positive 8. And then the plus 6. Alright, now when I FOIL this out, I'm going to get 3x times 3x is 9x squared. Alright, and 3x times negative 4 is negative 12x. Negative 4 times positive 3 is another negative 12x. And then a negative times a negative is a positive 16 minus 6x. And then I'll go ahead and combine these, that's a plus 14. Alright, and then finally, last step, just simplify. So minus 12 is 24. Minus 6 more is minus 30x. Alright, then I got a 16 and a 14 that I combine together. You can get a positive 30. So putting f into g gives me this. Putting g into f gives me this. So what you hopefully see here, and what's true in general, is that f of g is usually not equal to g of f. There are occasions where it is, but usually it's not. So it never has to be equal. In general, it's not equal. But again, there will be times we'll see where they are equal. All right, now if you have a number to put in there, instead of taking this and putting it into this, or this and putting it into this, and coming up with that equation, which we did, this is the exact same two functions. But instead of going through the process to come up with these two new equations for these combinations of functions. It's actually easier when it's a number rather than just x to take the two-step process, meaning put the number into the first function, f, and then get an output there, and then put that output into the g function. Okay, so let me show you what I mean. I'm going to take 1, and I'm going to plug it into f first. That's the first thing we come to. So I'm going to find f of 1 first, which is 3 times 1 minus 4. Alright, or you can put it in parentheses. So 3 times 1 is 3, minus 4 is negative 1. Now you take that negative 1, and that's what goes into g. Right? So 1 goes into f, and that spits out a negative 1, and negative 1 goes into g. So now I find g of negative 1, and that means plug a negative 1 in here and here. So negative 1 squared minus 2 times negative 1 plus 6, and then we just simplify. So negative 1 squared is positive 1. Negative times negative is a positive 2 plus 6. And then 1 plus 2 is 3 plus 6 is 9. So that's what I get when I plug 1 into f first and then g. Now, going back to the last slide, again, it's the same two functions. So g of f was the last thing we did here. And if I plug 1 into this, I get 9 times 1 squared minus 30 times 1 plus 30, which is 9 minus 30 plus 30, which 30s will cancel, and we're just left with 9. So I get the same thing if I plug the 1 into f first and then into g as I do when I plug it into this expression after I've plugged one function into the other and simplified. The thing about it is it's just a whole lot easier mathematically to just do this than it would be to find that function and then plug it in. Alright, so same here. I'm going to take negative 1, plug it into g first. So g of negative 1. Well, we know what g of negative 1 is. We just did it right here. So g of negative 1 is 9. I'm going to get 9 out. And then when I take that 9, I'm going to plug that into f. So negative 1 goes into g and produces a 9. And then that 9 is going to go into f. So f of 9 is 3 times 9 minus 4. So 3 times 9 is 27. 27 minus 4 is 23. Alright, and again, likewise, if I take f of g and plug in negative 1, so that was the one in red here. If I plug in negative 1, I get this. Negative 1 squared is positive 1, so 3 times 1 is 3. Negative times a negative is a positive 6. And then that's a 9 plus 14 is 23. So once again, I get the exact same thing. It's just this way is going to be quicker. Alright, again, we already did this work. So since we already had done the work, it's not bad to plug it into that. But think about having to come up with that and then plug the number in just to find f of g of negative 1. It's just going to be quicker to use that two-step process. Plug into the first function, get an output, and then plug that output into the other function. Alright, domain restrictions when you have compositions of functions. So first of all, when we did it in the last part of the 1.7 notes, it's everything in the original two functions f and g were both restricted. If there was a restriction here, it's a restriction in their combination. But with compositions of functions, f or the outer functions, the function you go into last, their restrictions are not included. So the only thing that's excluded from the domain is the things that are excluded in G. So the restrictions of G, all right, not F. It's not in the domain of the composition. And then anything that the output of G of X, after you put X into G, anything there that causes something to go wrong in F is excluded. Okay, so it's not directly the inputs of F that are excluded. It's the outputs of G that cause problems in the F are excluded. So I'll show you what we mean by that here in a second. All right, so part A, F of G of X. So we're going to take a number, plug it into G, and then we're going to take that output and plug it into F. Now notice G, the way it's written right now, X can't be 0. And F's restriction is X can't be -2. Okay. Well, what we're going to see when we come up with the domain here in a little bit, that -2 is going to end up being okay. And you'll see why in just a little bit. So even though it's a restriction in F, it does not end up being a restriction in the composition of F composed with G. Alright, so F composed with G, that means plug G into F again. So we're going to plug this function right here in where this X is. So what we end up with is 4 from the top, alright, divided by X plus 2. So I'm going to put the plus 2 there. So now it kind of looks like this, but the X I'm replacing with 1 over X. Now the way you fix this is called a complex fraction, a fraction within a fraction. You multiply through by the common denominator of every term's, the least common denominator of all these terms. Well, there's only one that has a fraction, so the LCD is that denominator, X. And then you just multiply. So this is 4X on the top. And then on the bottom, when you distribute the X through right here, since we are adding, X times 1 over X is just 1. And then plus 2 times X is 2X. So that composition 1 over X plus 2 is the same thing as 4X divided by 1 plus 2X. Alright, so there's our function. Now what's the domain of this? Well, the domain is equal to, X can't be 0, so we're going to say it's all X's such that X is not 0 because that was an original restriction of G, and that's what we're saying up here, is that the restrictions of G are always included. But now we have a new restriction down here, okay? Because this is a fraction, the denominator can't be 0. So we set that new denominator to 0. Solve. So 2x equals -1, x equals, divides both sides by 2, -1/2. So that becomes another restriction. X cannot be -1/2. So the other restriction is not -2, it's -1/2. Now why is that? Well, because the way these things work, X goes into G first, stuff happens, and then it goes into F. So for -2 to be the thing that goes into F, it has to come out of the G function as -2. Well, this is just the reciprocal function. 1 over X means reciprocal. So if -1/2 goes in, the reciprocal comes out, and the reciprocal of -1/2 is -2, that restriction. So that's what we mean. It's not, the restrictions of F are not important because those numbers directly, the inputs into F, are not the X's. The inputs into F are the outputs of this function. So this function has to act on them first before they go in there. So the restrictions are going to be determined by the outputs of G. All right, and then the last thing, given a function, can you come up with a composition? Can you come up with two functions that when I put them one into the other, I get this function? All right. So the one that you're supposed to look for, and when I say supposed to, I mean like as far as prepping you for calculus, is the outer function and inner function. So g of x is the inner function, f of x is the outer. So the way this is written, the way it's looks is G has to be inside of F. Alright, we'll put G inside of F to get this function. So it's kind of easy to see that this is underneath that radical, so it's inside of this other function. So x squared plus 1 is our inner function. So it's the one that's inside the other function. Now, you have to remember the way compositions work. This entire function goes into the input of this function. So when we write f of x, we just literally, if this is what we're calling the inside function, to get f, we're just going to replace that with x. So this is inside of a function that's the cube root of x, but x has been replaced with this to get this h function. So we put x squared plus 1 inside of what? The cube root of x. We just replaced it with the x. Okay, so again, just remember how compositions work. G goes into F where the x is. So if this were to go in where that x is, what would I end up with? I'd end up with the cube root of, instead of x, the cube root of x squared plus 1, which is what this says. So that's what we mean in this type of problem. Two functions that when we put one into the other, we get this. Okay, it's very important that h is made up of G going into F. So it has to be that this is inside and this is the outside. Now, it says find two functions. It doesn't say the two functions. And the point being there is there's more than one. There's more than one way to do this. So I could have said possibly that f of x is equal to the cube root of x plus 1 and g of x equals x squared. And that would have worked perfectly fine. Okay. There are actually an infinite number of pairs of functions that would give you this. And I'll show you where you'll be able to kind of tell after this. But let's say that I call this x the cube root of x plus 5. Everything, well, plus 5, that's a plus 1. Right, it is. But I could make g of x equal to x squared minus 4. And now when I plug this in for that x, I get x squared minus 4 plus 5. And minus 4 plus 5 equals positive 1. Alright, so because of this addition underneath here, it opens up the possibility of an infinite number of functions that I could plug in there. But the one that's important for you to understand, the one that you want to be able to get down for calculus, is this one. Okay, this is the one that I would hope that you could see, and not these other little manipulations that technically work. But what you're being asked really to do at the heart of this is one's inside the other. Who's inside, who's outside. Inner function, outer function. So this would be the one you would want to make sure you can see. But technically, there are a lot that work here. All right, and then there's the one that it's almost cheating because it's so easy to do it. But if you make f of x the outer function just x, well, now you can make g of x the same as h of x. Right, and now I plug this, which is h of x, into this function. I get this function back, which is now a composition. Okay, so this is like the cheating one. If you make the outer function x, you can make the inner function that you're trying to come up with, and technically it's right. Right, but again, this is the one that'll help you the most in calculus. That's the one that you want to be able to see, the literal inside and outside function.